To address the challenge set forth by IronDev, the GRILL team settled on a UAV search and rescue simulator. Before development started, core requirements were debated and set. First and foremost, the simulation would be distributed in multiplayer. Second, a mission planning phase would allow flight paths to be drawn collaboratively in virtual reality real-time on a small-scale landscape. Third, an information queue stores data pertaining to objects of interest the drones have found that participants can collaborate on answering. And finally, the simulation could be used in both military and civilian contexts. With these requirements set, the major emphasis was on being able to perform distributed teamwork and collaboration, as the military has been making a push to tie this into training as well. This is a major aspect in training, as it allows for trainees to be in separate geographic locations, but still work together to perform tasks at hand. Giving the trainees the ability to perform collaborative tasks better resembles the real world, as a majority of tasks get performed by a team of people. Also, making it distributed gives it the option to communicate with other training software if the proper network communication logic is implemented. Once core requirements were set, a small team set to work creating parts of the simulation in Unreal Engine. On starting, users are presented with a main menu that allows a new game to be initiated. Users assign themselves a username and then can host or join an existing game. The Advanced Sessions plugin was utilized to assist with multiplayer lobbies, as it provides more flexibility in hosting and searching for sessions than Unreal Engine's built-in functions do. Once in-game, users choose the role they wish to fulfill in the simulation. An instructor-operator role allows for oversight and observation of the scenario without having a direct hand in participating in the scenario. UAV pilot role allows for users to control the drones and identify found objects of interest. These UAV pilots can be in either VR or in desktop. Once all users have chosen roles and indicated readiness, the mission planning phase begins. Voice communication facilitates collaboration during all phases of the experience. Spawned into an Operations Center mobile tent, users are able to see and collaborate with each other in virtual reality. To speed up development, the GRILL team utilized the VR expansion plugin, which allows for VR characters to be replicated to each user across the network. This functionality is not natively supported by Unreal Engine out of the box. The Operations Center the users are placed in contains props and various displays upon which to conduct search and rescue operations. Importantly, the Operations Center contains a mini display of the landscape. This gives the users a small-scale representation of the landscape so that they can appropriately plan out the drone flight paths. Colored drones can be grabbed in virtual reality and moved around the landscape to create flight paths. These flight paths can be edited and tweaked collaboratively to satisfaction. Once flight paths are finished, users can proceed to the search and rescue portion of the simulation. Operating the drones is a critical function of the simulation. To lower workload needed, the physically accurate quadcopter plugin was used to provide realistic drone controls and physics. While the drones default to being idle, in which they sit and wait for a command, a user can override and manually fly the drone or set it to autonomous mode at any time. The current state that a drone is in is visually represented and displayed to the users. In manual mode, a user can manually fly the drone and manually mark targets of interest. Also, while in manual mode, other users who are not controlling the drone cannot issue the drone commands and can also see which user is currently controlling the drone. In autonomous mode, a drone follows the flight path that was detailed for it during the mission planning phase and autonomously marks objects of interest. Unreal Engine's AI navigation only supports ground travel out of the box, so to facilitate autonomous flight, the Dawn's AI navigation plugin was used. This plugin allows for an AI controller to accurately navigate the drones through the air and around obstacles to their next set location. Any object of interest is inserted into a shared log that is viewable by all users, which is called the activity feed. Any object of interest that is inserted into the activity feed, whether autonomously or manually, must be navigated to and dispositioned appropriately. Objects in the activity feed are separated into two groups, urgent and solved. Urgent contains logs that have yet to be answered, and solved contains logs that have already been answered. A user can update the current disposition of any log at any point in the simulation, even if it has been answered already. Objects can be dispositioned as a sign of life, a neutral, friendly, or a target. Each entry in the shared log contains an expandable thumbnail picture to give users an enhanced view of the object of interest. Users work collaboratively to observe the drone feeds, manually override flight, find objects of interest, and disposition the log. The GRILL believes the simulation could be the foundational framework for studies in distributed search, rescue, and reconnaissance. The views that users are presented with differ depending on what role they chose and also if they are on desktop or in VR. In the instructor view, the user can freely fly anywhere in the map to observe progress. They are given a HUD that allows for them to view an overhead view of the map, the activity feed, and the views of the different drones. A similar HUD is given to users who are UAV pilots on desktop. The overhead map view provides continual situational awareness through providing the current positions of the drones in the world. The activity feed allows for the users to see the objects of interest the drones have found and label them accordingly. The multi-drone feed provides controls for the users to issue commands to each drone individually, as well as see the current video feed of each drone. These drone views can be individually enhanced if a user wishes to view them on a single screen. In VR, this HUD is split up among various displays inside of the command center to offer a more organic feel. It's important to note that the VR users do not fly the drones from a first-person perspective. Rather, they are provided with a simulated AR drone view, which helps to decrease the amount of cyber sickness a user experiences. The environment is a large-scale and detailed landscape. Since developing such a landscape would require great time and effort, the landscape from the infamous Boy in a Kite Unreal Engine demo was used. Significant optimizations were needed in order to make the landscape performant and usable for the context of our project and in VR. Some of these optimizations included modifying how lighting and shadows render, and also cutting down on the total assets in the side of the landscape. The landscape is a vast mountainside that consists of lakes, rivers, and forests. We find that the landscape is representative of terrain and ecosystems that may be encountered during a search and rescue operation. A mesh of the entire landscape was taken and scaled down to be small enough to use during the mission planning phase. To create the small-scale landscape, the various models being used in the full-scale landscape had to be taken, scaled down, and combined into a single mesh. Entities are placed on the landscape pseudo-randomly, which ensures a difference between each scenario. Entities consist of friendlies, neutrals, signs of life, and targets, and are the objects of interest that the users are attempting to locate. Every year during IronDev, the teams are given a secret ingredient to show off their creative, technical, and artistic sides. The secret ingredient this year was that the future is now, allowing teams to add in elements showing off something they dreamed about years ago. Ideas about updating the drones in the simulation with sci-fi aspects were considered, and the Grill team ultimately chose to add in aspects of Star Wars. The drones were updated to look like TIE fighters, the models of the VR players were updated to resemble stormtroopers, a mouse droid was added into the operations center, and a Death Star was added into the Sky Sphere. To resemble the holograms that are used in Star Wars, the VR players had a holographic material added to them that the Grill designed. To speed up development, a variety of plugins were used in the project. The VR expansion plugin, which allows for multiplayer VR, Don's AI navigation, which allows for flight AI navigation, Unreal Engine's A Boy in a Kite demo, from which the main landscape was pulled, the Advanced Sessions plugin, which offers more flexibility when hosting and searching for multiplayer sessions, and the physically accurate quadcopter, which provides realistic drone controls and physics. Since the Grill team did not have a dedicated 3D modeler on the project, a variety of character models and object meshes were also harvested from the Unreal Engine marketplace. Outside of the plugins and marketplace content, everything seen was developed from scratch in a short period of time. Although 7 total developers worked on the project, when time is added up, about 2 full-time equivalents worked on the project over the course of several weeks. All of the different aspects of our project were integrated in a new and innovative way as it combines multiple aspects of what UAV operators perform. The pieces were dynamically designed so that the project could be easily tailored to resemble any number of the drone mission spaces. Additionally, users collaborate throughout the entire simulation in a distributed environment so that they do not need to be in the same geographic location to use the project. The Grill team has not performed the scale of integration for multiplayer before, so it created a large learning curve for the team to get over in order to get the user collaboration to work appropriately. There are several areas that the project could be improved upon. The introduction of real-world geospecific rather than geotypical landscapes would greatly improve the utility of the simulation. Voice communication is currently provided by an outside system rather than natively supported within the simulation. The minimap could be enhanced to geographically show where pictures were taken and allow a direct interface to the shared log from the minimap. In-game data of user performance could be recorded and saved for future review and use. The obvious real-world application of our project is to assist in the training of UAV operators and in planning out flight paths. However, it could be used for additional applications such as helping users build and improve their teamwork, collaboration, communication, and time management skills. The Grill is privileged to participate once again in IronDev, and we hope that you have enjoyed learning about our project as much as we enjoyed creating it. Thank you.